Right. What's today? 27th. 427. Is there anything exciting about that in like numerology? 427. I don't think so either. That's pretty boring. Anyways, this is snapshot number 5. So this is the full-on walkthrough, like how do you do it step by step by step. So the first problem that you need to do is by factoring. So 2x squared minus x minus 6 equals 0. Remember, factoring is the process by which we break it down into, well, they're called factors, things that multiply back to give us what we started with. So going into this problem, we know for a fact that there has to be a 2x and an x to make 2x squared. And then we look at the sign in the back, only the back. The back has a negative on the 6, so we know there has to be 1 plus and 1 minus. And we're fully aware of the fact that we might have to switch those. We might have to switch them to minus and then plus. Like, it's okay, doesn't matter. And then we look for numbers that multiply to make 6. We've already got the negative taken care of. And if you put in, by the way, there are 4 things you could try. You could try 1 and 6, 6 and 1, 2 and 3, 3 and 2. So there's really no like, I need help with this. If you try one of them and it doesn't work, it just means you need to try something else, right? So the combination that's going to work is putting a 3 here and a 2 here. So remember that's only part of the process, right? You also have to go further and solve the equation. So like if this is a factor, then it produces a solution of x equals negative 3/2. And this factor produces a solution of positive 2, right? So don't do all that hard work to factor and then not finish the job. You guys have any questions about that particular problem? Okay. How did you do it? That's the same thing as what I have.
Oh, okay.
Just backwards. This, it doesn't matter if they're backwards, like A times B, B times A. It doesn't matter. Yep, no problem. All right, number 2 is the quadratic formula. So the first thing we want to do is we want to pull everything to one side. So the problem says 8x squared minus 12x, and then it goes on to say equals positive 8. I don't want that. I'm going to pull the positive 8 to the left and make it negative 8. Now, there is nothing wrong if you dive right in and go. You could say A equals 8, B equals negative 12, and C equals negative 8. But I really would encourage you to always look for divisibility, common divisibility. Like you'll notice, of course, that all 3 of those numbers can be divided by 4. And bless you, you're not going to get it wrong if you don't do this, but your time doing it is going to be a lot harder than someone else who did divide. Bless you again. So if I divide all the numbers by 4, which I'm going to do for the sake of this explanation, I don't want to work with bigger numbers than I need to, then I shrink the equation down to 2x squareds minus 3x's and minus 2, like this. So I don't even want to entertain the top option, but mark my words, it'll come out the same, but you're going to just have bigger, like this number in your root's going to be way bigger. Every step along the way, you're just going to have a harder time. So A in my case is 2, and B is negative 3, and C is negative 2. And then I assume by this point in time that you've got the quadratic formula pretty well memorized. So first thing we're going to do is the opposite of B. And then we're going to go plus or minus a big long square root sign. The first thing that goes in the square root is B squared. Remember, that number is always positive because you're squaring something. It doesn't matter what it was before. When you square it, it's coming out positive. And then I'm going to put minus 4, and then I'm going to put a couple of blank multiplication spots. Later on, I'm going to fill those in. And then on the bottom, I'm going to do 2 times A, which in my case is 4. And then I am going to go backfill the A and the C values. And so A, I'm going to put in a 2. And then for C, I'm going to put in a -2. And at this point, it's imperative that you just ask yourself this question. I'm trying to coach this into you as a habit. Don't do any real math yet. Just ask yourself, is the inside of the square root going to be subtraction or addition? What's it going to be? It'll turn to addition because even though clearly I'm pointing to a subtraction sign, you see that later on down the line, he's going to have to interact with another negative sign. And so really what happens inside of the square root is it's just 9 plus, and then you do 4 times 2 is 8 times 2 is 16. So the next line is going to look a lot cleaner and sweeter than the line before. If I just do what's written in white up there, then I just get the square root of 25, and I arrive at this point. So it's from here, as I've said before, that there are 3 things that can happen. Number 1 is you could just be done. Like you could literally put a box around it. If the root were a dead root, put a box around it, stick a fork in it, it's done. The other option is you could get a root that's not dead, but is also not a square rootable number, in which case you'd break down the root, draw the triangle, reduce. And then there's option 3, which is this. And that is a square root that just is a number. They're called rational numbers. And so if I take this to the next step, it's actually now just 3 plus or minus regular 5 over 4. And that, as always, is our green light to press on, to take the pathways. If you don't like calling them pathways, it doesn't matter. I try to use something that for me feels visual, like there's a north pathway and a south pathway, I'm tracking them. So if I take the top pathway, what's 3 plus 5? 8. And 8 divided by 4 is, so one of my answers is 2. Now I trace the other pathway. I just literally reset and I go now and I take the bottom pathway, which is a subtraction. What's 3 minus 5? And -2 over 4 is -1/2. Done. Those are your answers. Piece of cake. And again, on a quiz, you'll see more. On a snapshot, I'm just trying to keep these short. So that's, like I said before, one of many things that problem can look like. The beginning of the quadratic formula is always the same. It's boring. The first 30 seconds are like you can sleep through it. But it's when you get to this point, I'm going to put a circle around it. It's when you get to this point that you have decisions, intelligent decisions to make. Do I simplify the root? Do I actually take the root? Or do I just call it dead and put a box? That's usually where the boo-boos start to happen. Anyhow, question 3 down in the lower left corner is the one where we have to use square roots. And again, this is just one of a few different flavors. Just because this is a square root problem doesn't mean that all square root problems behave just like this. It's just a sample. So the problem starts out with 3x squared minus 5 equals 91. You have objectives, but your primary objective is to get that thing in the yellow by itself. So there will be no square rooting shenanigans until you've gotten the yellow box by itself. So step 1 is to add that 5 across and get 96. Step 2 is to divide by 3, and you wind up at this juncture. And this is generally where you should get to when you now have to do your thing. And your thing is taking the square root of both sides. So when I take the square root of the left side, I get x, and then I write equals positive negative. And having graded 30 or 40 of these, the most common mistake I saw with this problem was people still butchering the square root of 32. And you should have something in your notes, like even if it's this sheet that has all the roots and stuff on it, or if it's your own page of notes or something that you've created, I don't care. But at some point we have to stop messing up these death numbers. And I tried to give you fair warning about the numbers that we don't like. And one of those numbers, I think if you were to go back and watch that video from like a month and a half ago, the first death number on the board was 32. And the only reason I run that interference is to try to get you to understand that hundreds and thousands of kids before you have screwed up the square root of 32. Your 4th grade instincts are going to want to tell you to say 4 times 8. because someone got paid to get that stuck in your head. And then I have to come and try to get in the way of that and convince you stop using 4 times 8. You must use 16 times 2. Simplifying a root isn't about just simplify it a little when you feel like stopping, stop. It's about going all the way. And 32 will always break as a 16 and a 2. And what's the square root of 16? Always will be. So my answer is positive negative 4 root 2. Do not use 4 times 8. If you haven't done it yet, if you haven't into your notes made a place for this, you should find a place to add the square root of 32 and the square root of 48 and the square root of 80 and the square root of 72 and the square root of 96. And I could make more. The trouble with these numbers, the death numbers as I call them, is that they make you want to say things that you shouldn't say. Like this one has to be root 16 root 2. This one has to be, do you guys remember 48? It is, it's 16 and 3. And again, that's not what our training in grade school brings us. Our training gives us 6 and 8 and 4 and 12. Sorry, you have to train yourself to see numbers a certain way. Do you remember what 80 should be? Yes, 16 and 5. Do you remember what 72 needs to be? It's not 9 times 8, even though you want it to be. I don't care. What is it? It's not a 16er. It's a 36 times 2. What do you think 96 is? 16 and 6. And so again, there's having these in your notes helps because when you see them, and I'm not saying if, when you see them, then you know how to attack. You've got your strategy. You don't have to reinvent the wheel every time. Every time you see 48, you don't have to grind your way through the red list. Just have it in your resources and just know, I know you. I know exactly what to do, right? But you got to stop screwing those up because it's just kind of annoying, like we don't want to be holding ourselves back with something like that. Something we could just memorize or put in our notes. The last problem on the snapshot, I'll put those back up in case you were writing those down. The last problem on the snapshot was the completing the square. And I tried to keep this one just as simple and straightforward as I could. So I have x squared minus 12x plus 12 equals 0. What do we do first to set this up? Move the 12 to the other side, right? So what we're trying to do is we're trying to basically clear a landing pad in this empty space right here for the act of completing the square. When the 12 moves to the other side, he becomes negative 12. This far along in the school year, there should never be an instance in which you move something across an equals and forget to change the sign. It wasn't cute or acceptable in November, and it's certainly not cute or acceptable in almost May. So when you move it, switch it. That's all there is to it. Left, right, doesn't matter. No one cares. And then begins the algorithm. What is half of minus 12? So I'm going to write down minus 6 over here. And I've shown you before why I write that down. You should too. Minus 6, when you square it, brings you what? So I'm going to put plus the answer to that, plus 36 here. Trying to color code this for you. Notice I did not use the purple number to add to both sides. I squared him first and then added that to both sides. The reason the purple number is still written over there is because now when I complete the process, and the next step is factoring, I always know to write x here, but then the other part of it is just taking that purple minus 6 and done. And I realize you can't grab things with a pencil, but you get the point. Like you can just copy it, right? It's nice to have it laying around. And then on the right side, you got a little rinky-dinky kitty math. What's negative 12 plus 36? Good. So we made it to this part. And now we take the root, the square root of both sides. And when I square root the left, I get x minus 6. I instinctively write equals positive negative before I do anything else, so I don't forget. Do it right then. What is the square root of 24? It is. It needs to be broken down as a branch, root, very specifically using 4 and 6. Every number has a way that you should simplify it, and that's 24s. So that becomes 2 root 6. And then the final step, move this minus 6 and tuck it right there and rename it as positive 6 when you do that. So you get x equals positive 6 plus or minus 2 root 6. Done. Good. So like I said, the rest of today, you can have to just get caught up on assignments. Monday, I don't know what Monday will hold. Let's just take it one day at a time, I guess. But we'll leave that here. We'll let that simmer. I'll post that up on the old YouTube, and that's that. And I'm just right here. If you need help, just let me know. I would love to help you.